Okay, so here we have discussed what I was discussing in the last class is uh, that when we move from sodium to silicon, the ionic radii decreases, and it is because the number of electrons are remain same. So if you see over here, we have same number of electrons in each one of the cation, and number of protons are being increased. So what would happen? The forces would getting more stronger, and as the forces of attraction would get more stronger, then the size would decrease from sodium to silicon. Is this understandable to everyone? If anybody have any doubt, kindly ask. जी बेटा सबको क्लियर है? Yes. Is it clear to everyone? Okay. Now, who left the class? Adil Hamza is here. Sharia is here. Okay. So here we have ended over here. Now the next point. When we move from phosphide to chloride, the anionic radii decreases because repulsion among electrons in outermost shell decreases. Okay. And what is the repulsion and how this repulsion between the electrons are decreasing? Let me, explain it to you. So if we compare again, so now we are comparing the rest of the three elements ions, which would form anion. So here it's a phosphorus with a 3 negative charge. Then after phosphorus, the next we have sulfur with a 2 negative charge. And then we have a chloride with a 1 negative charge. Okay. So if we look for the protons and then electrons in all the cations. So here you have 15 protons, 15 positive charge. Here you have a 16 protons, so 16 positive charge, and here you have a 17 protons, so 17 positive charge. 3 negative is indicating that it have a 18 electrons. So it would be 18 negative. Then it would also be 18 negative, and this would also be 18 negative. But so all of them have 18, 18, and 18 electrons, right? Okay. So if you compare protons and electrons, you can say that it have a 3 extra electrons. This one have a 2 extra electrons, and this one have a 1 extra electron, right? So here in this case, as there are 3 uh, extra electrons, it means where the repulsion between the electrons is significant or more important. So that's why the electrons are further away, and the shell and the ion of the radius would be greater. So here we have a radius like this over here. Then we have a little smaller radius than this one. And then we have a little more smaller radius than this one. So we have to keep one more thing in our mind, that the see, it is actually smaller than the first one. And it is also smaller than the next one. So I can label them as phosphide 3 negative ion, then sulfide 2 negative ion, and then chloride 1 negative ion. Yes, is this clear? So the decrease in size and ionic radius across the period is due to the decrease in the number of extra electron. Okay, so the next point over here that you must have to keep in mind, that's what I have told you earlier in the start of this ionic radii discussion, that the cationic size is always smaller than the anionic size in the same period. So in the other way, we can say that the smallest anion is larger than or bigger than the largest cation of same period. And it is because of yes, is this point is understandable to everyone? Yes, is it clear to everyone? Okay, so now have a look at the graph. The examiner asks the graph sometimes, so you know that how to show the graph. So the graph would be like this. We have discussed the graph over here in the atomic radii. Here, there is a graph for ionic radii. Okay, is this graph is clear to everyone? Yes. Okay. Next thing that we are going to do, or the next trend that we have to discuss is just give me a minute, please. Now the third one. Is the melting point. Okay. So to see the melting point trend over here, again, first take these elements, the elements from the period 3. So if we look out of these, non-metals, it's a metalloid, and these three are metals. Okay, so we have to compare their melting point depending upon the structure and the bonding. So first I can conclude that, am I audible to everyone?
Yes, sir.
Okay. So from sodium to aluminium, the melting point increases due to increase in strength of metallic bond, which means metallic bond gets actually stronger. It is because the number of electrons moving free increases. Is this point is clear to everyone? So if you see over here that sodium have +1, magnesium is 2 plus, and aluminium is 3 plus. So here sodium is losing 1 electron per mole per atom, magnesium is losing 2 electrons per atom, and the aluminium is losing 3 electrons per atom. This actually indicating me that the number of free moving electrons are increases. Is this clear? So I can write over here or mention over here 1 mole. Okay, do this way. Amount of each substance and then number of free moving electrons. So if you see here, for example, if I took the 1 mole of each one of them, then here we have 1 mole of electron. Here we have and here there would be 3 mole of electron. Is this point is understandable to everyone? जी इसमें किसी को कोई कंफ्यूजन है तो प्लीज पूछ लें. Okay. So here I can comment that the melting point increases from Na to Al. Now, silicon have the highest melting point among the elements in its period it is because it's so due to giant covalent structure, the silicon have the highest melting point. Is this understandable? If anybody have any confusion till here, do ask. Okay. Then from no, we are talking about elements. Sorry, we don't make these ions. So from phosphorus to chlorine, these are okay. These are simple molecular structures. So but if we look at these structures, what would we find? That phosphorus is tetraatomic, P4, and sulfur is octatomic, which means S8. So the melting point of sulfur is greater than the, who joined the class, Abdullah? Just give me a minute, please. Okay. So where were we? That the melting point of the sulfur is greater than the phosphorus due to stronger van der Waals forces. So then the P due to the stronger van der Waals forces between sulfur molecules. So between the sulfur molecules, just give me a minute. Okay. So if we compare the structure, let's recall phosphorus is 15 and sulfur is 16. So if phosphorus exists as P4 and sulfur exists as S8. So in this P4, phosphorus have a bonding like this in the P4 molecule. So here if we look sulfur, so its octet 8 molecule atoms containing molecule would be just like a crown. So it's S8. Now, if you recall, phosphorus have a 15 electrons. So in this whole molecule, P4, there are only 30. No, sorry. There are 60 electrons over here. And here, 16. So 16 times 4 gives you 64. And see over here, 128 electrons. So obviously, the forces of attraction between sulfur molecules would be more greater than the forces of attraction between the phosphorus molecules. Is this clear to everyone? Okay. Now, chlorine is diatomic and argon is so chlorine is Cl2 and its argon can be drawn like this, but you cannot draw argon. Okay. So if you look over here, it have a 18 electrons. So 34 electrons over here. Yes. Is this clear to everyone? So if we look into the graph that examiner asked, okay, just give me a minute, please. Just a minute, it's not the correct one. Some portion of the diagram is missing. Sure, why I'm not getting the one which I'm looking for. Just give me a minute, please, everyone. So see, this is the trend that you need to show, but there is one important thing over here, that sodium is +1, right? And magnesium is +2. So from sodium to magnesium, the melting points gets double, but sodium magnesium to aluminum, it increases a little. जी ये ग्राफ तक यहाँ तक सबको क्लियर है? जी इस ग्राफ तक किसी को कोई कंफ्यूजन है तो प्लीज पूछ लें. Okay. Then next we have electrical conductivity. So from sodium to aluminium, so the electrical conductivity electrical conductivity increases because of because of C of delocalized electrons increases. The reason behind over here is this only. See, when you move from sodium to magnesium, the difference actually doubles. But when we move from magnesium to aluminium, the difference is increased by just half of magnesium charge. So that's why there is a not that much greater difference between the melting point of magnesium and aluminium. Is this clear?
Yes, sir.
Okay. So the electrical conductivity graph
थोड़ी सी मदद कर दें, एक दो बुक बहुत देगा आपको.
So the delocalized electrons increases, and as a result, the electrical conductivity increases. But when uh, we look into the further points from here, the next element is silicon, and silicon is semiconductor. So it also conduct, but not as much as the metals. Okay. And the rest are, we know that non-metals, and they do not, show conductivity, or their conductivity is very smaller. So if I take period 3 elements over here and the conductivity over here, so first, from sodium to magnesium to aluminum, then silicon, and after silicon, phosphorus, sulfur, chlorine, argon. Even you put these them little more smaller. So here, so if I mark them, so it's sodium, it's magnesium, it's aluminum. Here I have a silicon, phosphorus. No, yeah, silicon, phosphorus, sulfur, chlorine, and obviously if it's there, then it's an argon. Okay, is this trend is understandable to everyone? If anybody have any doubt, do ask, please.
Yes.
So the next trend is about ionization energies, and you all are very much familiar with the ionization energies, the first ionization energies. Okay. So the ionization energy graph, you all are familiar with that ionization energy trend. So here we have this trend. And if you recall, from magnesium to aluminum, the decrease in the ionization energy is that the electron went to p subshell, and here the electrons are in 2s. So the p subshell is further away from the nucleus. That's why their ionization energy decreases. Then from phosphorus to sulfur, there is again dip in the ionization energy. It is because here we have a pair of electron and here there are possibilities that no pair of electron over there. So this is the so actually till here we have completed all the trends of the group 2 or sorry period 3 elements. Now from here onward we are going to start with the reactions of period 3 elements. Okay, so give me a minute first. Okay. Mhm. So the first reaction that we are going to discuss over here is the reaction with oxygen. It means we are going to discuss how each element of period 3 would react with oxygen. Okay. Okay. So my screen is shared with all of you. Okay, let's start with the reaction. So first, the reaction with the oxygen is actually a combustion. So here in this reaction, sodium burns with a yellow flame. Okay. So what would happen over here? Let's see, this is a sodium metal. When it comes in contact with the oxygen gas, the reaction start happening. And if you recall, sodium is in group 1, so +1 charge, and oxygen is group 6, so -2 charge. So the formula would be Na2O. To balance this equation, I have to put 2 over here and 2 over here. No, sorry, a 4 over here. Now the my equation is balanced, right? Okay. Now the other important part over here is we have discussed the observation, but beside this observation, the compound that we got over here is, this is a giant ionic compound. Its structure is a giant ionic one, and the other one, it's an alkaline in nature. It's alkaline in nature. Okay. Now, next reaction is with magnesium.
सर
So,
आयनिक हमेशा जाइंट होंगे?
yes, ionic all are giant. They are not molecules. So with oxygen, magnesium burns with so it burns with a brilliant white flame. Okay. Now if I would write the equation, I have a magnesium solid reacting with the oxygen gas. So magnesium have a 2 positive charge and oxygen also have a 2 positive charge. So the formula would be MgO. And to balance this formula, I have to put 2 over here and I have to put 2 over here. Is this clear?
Yes sir.
Okay. Now, one observation was that the brilliant white flame is observed. Beside this, the other two characteristics that we say about this magnesium oxide is, again, it's a ionic substance, so it's a giant ionic. And here, the above one is a base, the above one is an alkaline. So this one is a basic, which means it is only slightly soluble. Okay. Is this clear to everyone? Now, next. One, the reaction with the aluminium. So for this reaction, aluminium must be finely divided into small parts because of its oxide layer. Okay. And there is no observation like this that a flame. So there would be, and you are not going to observe any flame over here in this reaction. Okay. So here I have aluminium reacting with oxygen, and then if you look at the charges, aluminum is 3 positive and oxygen is 2 negative, so it would be Al2O3 solid. And to balance the equation, 2, okay, wait, 2 over here, 4 over here, and 3 over here. Now, the aluminum oxide is a solid that is formed. I can comment on its properties. First one is that it is also a giant ionic, and the next one is that uh, it's amphoteric in nature. It's amphoteric. Is this understandable? Yes, is this understandable? Now, next part is we have a phosphorus silicon first. Okay. So in the reaction of a silicon, the reaction would occur in a normal simple way. No flames are observed again. And this reason is that the bonds are very strong. The bond is very strong. The bond is very strong. So there would be no flame observed. So the equation would be silicon solid reacting with the oxygen gas forming silicon dioxide SiO2. It is because Si have in group 4, so 4 positive and oxygen is 2 negative. So we would get this structure. And when I comment on the type of the structure, okay, 1 minute, it's not gas, it is also solid. So now it is giant covalent. Okay, it's not giant ionic, it is giant covalent. And the other thing is that it's acidic in nature. Is this clear to everyone? Okay. Yes, is this clear to everyone?
Yes, sir.
Okay. Next, after silicon, the next element in the period 3 is phosphorus. Reacts vigorously, and here again uh, yellow white flame or pink white flame is observed. Okay, and if I go for the equation over here, a phosphorus solid when reacts with oxygen, we would get P4O10, that is a phosphorus oxide. That its formula you must need to remember over here. So to balance the equation, I have to put 5 over here and 4 over here. Okay. So if I comment on the properties of this oxide, so one is that it is a simple molecular. Now the other one is, it is also acidic in nature. Okay. Next we have sulfur. Sulfur reacts with brilliant blue flame. Okay, you must remember the name of this one. We already discussed it in redox as well. It is phosphoric 5-oxide. Okay, so sulfur reacts with a brilliant blue flame, and the equation would be sulfur solid reacting with the oxygen gas, forming sulfur dioxide gas. So again, it's a simple molecular. And acidic. Okay. Now, there is another thing that you need to remember, that this sulfur dioxide gas form over here reacts further with oxygen. And as a result, it turns into another sulfur trioxide. Sulfur oxide, which is sulfur trioxide. Is this clear to everyone? Yes. Yes.
Clear,
If
sir.
any, okay. But now you need to know these equations. These equations are actually asked in the exam. Okay. Now, in the first reaction, what we did, that the reaction leads to the formation of the oxides from the elements. Now, here I am going to discuss the reaction of oxides with water now. How these oxides are going to react with the water. Okay. Just give me a minute. Oh, sorry. Okay. My screen is shared again.
Yes, sir.
Okay. The first oxide that we got is sodium oxide. On reaction with water, what would happen? That it dissociates into ions forming sodium aqueous, or and actually we get 2 moles of hydroxide ions aqueous as well. You can write this in this way, or you can just write this as NaOH aqueous as well. Okay, so that is the first reaction. And if I have to comment on this reaction, this is an alkaline solution or an alkali because it completely dissolves in water. Now, the next is magnesium oxide. It also easily dissolves in water, forming in the same way you can either write the whole compound or split it into ions, aqueous. But in this case, it is slightly soluble. It is not completely soluble. Okay. Then afterwards, we have aluminium oxide with water and silicon dioxide with water. So here there is a no reaction that is take place. Okay. So in these two cases, there is no reaction with the water with these oxides, because aluminum oxide and amphoteric oxide forms a layer which actually protects the oxide layer, which so it doesn't dissolve in water, and silicon oxide have a very strong bond, so it also doesn't dissolve in water. Now, the next oxide we have is P4O10. That is a simple molecular, right? So here, what would happen? That phosphoric acid would form H3PO4. To balance this equation, I have to put 4 over here, and I have to put 6 over here. Now the equation is balanced. So the acid formed over here, we call it phosphoric acid. Now, the other oxide is SO2 gas. When it dissolves in water, what would happen? H2SO3 would happen. And what is H2CSO3? It's an acid, and it is sulfurous. Okay. And then we have the next sulfur oxide, that is sulfur trioxide. On dissolving in water, it turns into So we call it sulfuric acid. जी यहाँ तक क्लियर है सबको? जी यहाँ तक अगर किसी को कोई कंफ्यूजन है तो प्लीज पूछ लें. Okay, then now we have our next reaction, that is reaction of these elements with chlorine. So in these reaction, how we perform these reaction, that dry chlorine passed over the heated element. Okay. Okay, I am ending the class over here, and we will have a next class tomorrow. And tomorrow we have a class from 4:30. I hope everybody is available at 4:30.
सर मेरा
Sir, I have
confirm
physics class.
Okay. So it's
सर
Wednesday.
मगरिब के बाद क्लास रखें तो बेहतर नहीं होगा?
मगरिब के
तरावी
बाद ना बेटा कोई और हिम्मत भी नहीं बचती उस वक्त तो क्लास लेने की. मेरी खुद